So under each of the, so you've got the SEM and so on.
Yeah.
And we talk about the diagonals, but in that matrix, are those simply the critical ratios repeated?
Those are the correlations.
The correlations, that is what
Those are exactly what they are. So we paste the correlations table in there.
Yeah,
All I'm doing is cutting and pasting those over.
I went to look back a couple times, but the correlation table goes away.
When you hit reset.
But then it goes, well.
Oh, back to the table you pasted. Yeah, it goes away. Yeah, I've adjusted things a bit. All right. Oh, I think we're live. Cool. Excellent. Oh man. Let's see. One time, one of the lady students in one of the cohorts was listening to several of my videos in a row, and her husband comes to the room and says, "Who you got in there with you?" It's just James.
What are you wearing, James?
Yikes. All right, let's see. Share my screen. All right, we are missing a lot of people. We're going to hold up for a bit as we wait for a few more people to show up. Oh, maybe in the other room. Oh, so they shouldn't be, unless they're going to... Oh, okay. Nope. Yeah, I tried to get this room all 3 days, and they couldn't have it, and I kept trying to get that room all 3 days and wouldn't have it. So, really, I wanted to be in the other building. It's a lot nicer. Let's see. Let me pull up. Cool. Let's see, looks like we have most people in Hangouts. That's good. Hangout folks, we're just gonna wait a few more local people having trouble getting up in the morning on a Saturday. So. Yeah, me too. I don't know if any of you caught the news. Mitt Romney and Alexander Holyfield duked it out. Was it last night, I think? Yeah. They're supposed to save 40,000 pairs of eyes. Yeah, right. Oh, man, that's like a double-double. Wow. No. Yes. Nice. I didn't watch it. I just saw the news afterwards. But.
I saw a little clip. It looked more like a pushing show.
Oh, I'm sure. Yeah.
Did you see the stereo? No.
Oh, Huh? That's awesome. Did Mitt put any slap-on tattoos or anything? Wash-on tattoos? That'd be awesome. All right, looks like we got most everybody here. So we'll get started. So today's our last day, which is, I would love to say bittersweet, but it's mostly just sweet. I'm exhausted, as I'm sure you guys are too. That's why we call it a boot camp. So today we're going to talk about several things. Mostly it's causal models, structural models, same thing, sort of. And that involves mediation, moderation. We're going to talk about control variables and a bunch of other things, probably. See how things go. I've included some stuff in these slides that I've actually never taught before, so be some experimentation today, and I'm sure there's going to be lots of really, really hard questions on mediation, so that'll be fun. We're also going to talk about multivariate normality, like homoscedasticity. We're going to talk about multicollinearity, also a couple things that I haven't taught in this way before, so we'll see how it goes. Yesterday, we ended with, we did invariance and CMB, and then we imputed composites. As a refresher, what you do is you take your non-grouped model, and if you don't have common method bias, you take away your CLF. You do a final check, which we didn't do. You do a final check on your model fit before you run your composites. The reason being, during the invariance checks and the CMB, you might have had to adjust things, add a covariance, remove a covariance, remove an item, add an item sometimes. And so at that point you need to go and check your final model fit for the final CFA, whether that's with or without the CLF. Before imputation, you got to check your final model fit. And again, if you had method bias, this would include the CLF or your marker variable. So ours looks pretty good between 1 and 3 on the C-min or DF. Above 0.9 for us. You guys want to see? Come on. Let's see. No, not that one. This one. Sorry. Yeah, speak up sooner. Let's see if we get it. Duplicate. How many projectors thinking? Maybe. Please work. Well, that'd be rotten if this didn't work.
It's on. I think it might be your feet or your inputs.
Oh! It's not plugged in. Sorry. I wonder. Sir, is your computer turned on? Yes! Have you plugged it in? Are you using your DVD drive as a coaster? Let's see, here we go. Sorry for fail this morning. Okay. Let's pull this over. Okay. You can see more desolation. Let's see if we can get yeah, there we go. Okay. That looks good. All right, so where we were. So we need to do our final model fit on the CFA that we ended with. And so I just ran this, and it looks like we're pretty good. 2 on the C-min over DF, which is where we want it. CFI is above 0.9, and for us that's fine because we have a very large sample size, fairly complex model. Again, if you look at the hair book, which I have with you, if anybody wants to take like a photo of that table, they can. It's in the hair book here. The one that says this is the threshold you need for this sample size and this model complexity. And let's see if we're good on the RMCA. Yes, we are less than 0.06 and greater than 0.05. So at that point we're good. I would report all of these values, including the SRMR, and say this is my final measurement model fit. And I usually report that with a threshold. Like here's the recommended threshold from, most of them are from Hu and Bentler, I believe, which is in this folder, I think, references Hu and Bentler cutoff criteria for model fit right here. So most of those are in there as well. So you can reference those as the cutoff values and say you were good. At that point, you impute composites, which I've already done, but you go analyze data imputation and impute. Yes?
So you put this model fit at the end prior to imputing the scores. But for configural invariance, if your chi-square difference is showing an issue, you also report the 2 model fits there to prove that they are that there's good model fit.
Yeah, so there's one other time we report model fit in the measurement model, and that's during the configural invariance test.
So we put it 3 times, twice, but
Twice.
Yeah, there's a comparison.
Yeah, and at that point we aren't going to report the whole thing in a table. We're just going to say we ran a configurable variance test. We observed excellent model fit when the models were constrained. In parentheses, C min over DF this, arma CA this, D close this. Yeah, or CFI. But that would be a single line, one sentence in your report. Whereas this, you'd provide a table for this probably. Okay. Now, you can impute composites, which is what I recommend when you're doing fairly complex models like us, like what we're doing, including interaction. But again, you could just draw a causal model. I'm going to, we did that yesterday, right? We took out some covariances, true regression lines. You've seen that. So I'm going to jump straight to the causal model with composites. And everybody should have that data set. It's in the Dropbox in the data folder called composites. So everybody can use that or their own. File, new. Before I get started, I don't know if you can see, the canvas is just like a regular sheet of paper, portrait style, but we're going to be drawing a horizontal kind of landscaped model. So I'm going to change the way this looks. I'm going to go to View, Interface Properties, and change the page size to Landscape A4. Or you can do Landscape Letter, which is pretty big too, I guess. Apply. There we go. And now you have a broader canvas to work with. Yeah, View, Interface Properties. And it's just on that first tab. You can choose the page size, paper size. It's defaulted to Portrait Letter, I think, but I like to do Landscape Letter or whatever size you want. Anyway, that gives us a little more room to work with. I'm going to pull in the data. For me, it's the composites data. And 377 responses, good. Okay, let me pull up our model. This is the model we want to test. Now, before we go throw this all in there, the question is, do we test it all simultaneously, or do we test it bit by bit? Do we include all the variables, some of the variables? We don't have interactions yet. We haven't built those. So what do we do? And this, I would say, depends a little bit on your theory. Yes?
This is a silly question. This here was not drawn.
No, I drew that in PowerPoint.
Okay, so those not
They don't have error terms right now. It's just a conceptual model. Yeah, we'll draw the real thing in a sec. For now, I'm just going to throw in all of our main variables, all 7 of them. So go to the stack, go down to the bottom. We have usefulness, enjoyment, decision quality, atypical use, playfulness, comprehensiveness of use, info acquisition, and that's all 7. Are they in the right order is the question, or the right space? Usefulness, enjoyment, I'm just going to switch those to make my life easier. Okay, and that is an ugly mess. Good. There we go. To make it maybe a little more aesthetic, I'm going to push these out to here. One cool thing you can do plugins resize observed variables, and that'll make everything the same size. Ooh. So if you're OCD like me, yeah, plugins resize observed variables, makes them all the same size. Yes. Uh-oh. Like, Roy, can you fix it or no? I'll be right back.
Oh my goodness.
Yeah, if you drag your variables in and it's showing the full item description label, then it'll be norms to the interface properties. Miscellaneous tab. Oh, there you go. And then display label, I check that. And then you can go ahead and resize. Go ahead and do plugins resize. Yeah, that's good.
Does undo work on all the
I don't know if I can do work plugins because they're macros. Yeah, so they're not logged in the sequence of events. Okay. Now we also have control variables. I haven't thrown those in. I should throw in the controls because anytime you test a causal theory, you need to test it with controls included because they're part of that theory. You're saying, I think usefulness affects information acquisition when controlling for age and gender and education. So let me throw in age, gender, and education. Age, gender, education. We should talk about these guys too. Age, continuous, no problem. It works out in regressions, piece of cake. Education, sort of ordinal. So, in the sense that didn't finish high school is less education than finished high school, is less than some college, is less than undergrad, is less than graduate, is less than postgraduate degree. And so in that sense, we can say, well, an increase in the variable education leads to an increase or decrease in whatever else. So in that way, we can use it just normally in a regression like this. We don't have to create dummy variables or treat it as some sort of categorical and nominal variable. Gender. No, age is just an exact number. 22, 23, 24. Gender is another funny bit. If we asked for just male and female and didn't have an other or don't want to respond option, then this is a binary variable. That's how I have it. And binary variables are funny. They're not continuous. I can't say an increase in gender leads to whatever, because what is an increase in gender? That's just weird. Unless I guess you're taking hormone therapy or something. I don't know. Increase your gender that way. But because it's binary, it's already set up like a dummy variable for a categorical variable. So we can say when we observe some sort of effect from gender, we can determine whether the effect is greater for males or for females because it's binary. And I'll show you how to do that. It's sort of like we did with logistic regression. It's always relative to the other. So I'll show you if that didn't make any sense. We'll get there. Let's draw some lines. Our model dictates. We see full mediation going on. I haven't even talked about mediation. Maybe we should talk about it. We'll draw the lines and then I'll talk about mediation. And I'm going to draw even the line that we don't observe here. So I don't observe a line from playfulness to information acquisition, but it is assumed when I'm talking about mediation.
So,
yes?
by putting all those in, so we lose more parsimony.
We certainly do. Let's see, am I missed? I'm doing this all out of order. Okay. So the question was for remote folks, do we lose some parsimony when we include every single line? Yes, we do lose parsimony. We're losing degrees of freedom. And what we're going to end up doing, hopefully, is removing some of the direct effects from the IVs to the DVs. But in order to test mediation, we want to include them to start with. So this is an ugly, ugly mess. Covariances between the exogenous variables. Need errors on endogenous variables. I'm going to stop once I get this all rounded out so everybody can catch up. And name those unobserved variables. And then I'm going to clean it up so it looks a little bit prettier. Thank you. Atypical to decision quality. There we go. Move some things around. It's kind of ugly. Okay, let's see. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. We're missing one there. Playfulness to decision quality. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 2, 2. There, I've got them all in there. Okay, I'm going to sit and answer questions and let you catch up for a sec. Yes?
So gender and education are control variables, and we're putting the control variables on the dependent variable.
Yes.
Would it make sense to put it on only the exogenous variables, or no?
So when we use controls, we're saying that some IV predicts some DV even when controlling for the effects of these controls on that DV. And so we could, if we want to control for the potential covariances between the exogenous and these control variables, we could covary the controls with those IVs. I'm actually going to covary age and education and age and gender, because we already know from what we learned on Thursday that these are related. And because of that, education and gender are also related, because possibly these were mostly sophomores. We'll see. Do you have to covary control variables with everything that's exogenous? Depends on who you ask. If you ask me, the answer is no. Only if they should be. Theoretically, if they should covary, if they should be correlated, then I would definitely add it. Will it affect your model fit if you don't add it? Yes. If they truly are correlated, it'll affect your model fit poorly if you don't covary them. They are controls, yes. No moderators yet. Correct. Yeah, I've only modeled mediators, controls, no interactions yet, no moderators, multi-group moderators yet. You could if you were testing mediated moderation or moderated mediation, but who wants to do that? Some people do. I just helped write a paper where we have moderated effects, but it was the only thing that made sense. So when testing your theory, your hypotheses on moderation, yeah, which we'll do at some point. All right. Are we roughly to this point? Okay. So we have the model drawn. I'm just going to run it, and we're not testing anything right now. I just want to see that it runs, and then I'm going to go to the slides, and we're going to talk about some things before we start actually testing hypotheses. Before I run it, I've got to save it. This is our path model, sort of our initial path model. Got to select some analysis properties, output. I'd like to see modification indices and standardized estimates for now. Eventually we'll need indirect and direct total effects. We'll catch those later. And I'm going to run it. Proceed. It's going to say you're not covarying all your controls with all your exogenous variables. I say, yep, that's fine. It ran, hit the up arrow. The up arrow means freeze, by the way. Down arrow means unfreeze. Click on standardized estimates, and we have a bunch of numbers. Cool. Where are the R squares? Should be showing R squared. Did I not? Oh, I didn't. Squared multiple correlations. Got to check that box as well. It's right under standardized estimates. I'll run this one more time. Here we go. Okay. So what do we see? We see a bunch of effects. We can eyeball this and see potentially what's probably not going to pan out and what will pan out. The R square on information acquisition is very high. 46% of the variance in information acquisition is explained by these variables. 36% in decision quality. It's awesome. Atypical use probably doesn't have any effect on usefulness at all, or on information acquisition, possibly on decision quality, probably not on enjoyment. Just looking at the size of these estimates, atypical use looks like a bit of a dud. Comp use, even though I thought it was going to be a dud, as 0.21, 0.04, 0.08, and 0.15, so possibly an effect on the mediators. Playfulness, pretty good effect. Mediocre effect, no effect. Strong effect. Playfulness to enjoyment, that makes sense, right? Luckily, our mediators have a strong effect on our dependent variables. 0.43 here, 0.5 here. Usefulness is a very good predictor of information acquisition decision quality. Enjoyment is also a good predictor. 0.18, 0.28, I guarantee those are both significant. So just looking at it, I can say we have something going on. We're not going to end up with nothing, which is great. Our Negative 0.05. Oh, right here. Probably not significant, so the negative doesn't even matter.
So we probably believe the past depend upon our theory.
Sorry, what was that? Hangout person just texted me.
Oh, I think I answered my own question when I said it out loud.
Okay.
So if it's negative, you would say that probably delete the count.
No, so if it's negative, you got to look at the amplitude. So right now we have a negative 0.05 here, a negative 0.08 here. If these were negative 0.25, negative 0.55, those are real, those are meaningful, those are inverse effects. That means an increase in one variable leads to a decrease in another variable. And so they're likely significant. These ones, though, these little itty-bitty ones, probably not significant. I can guarantee that negative 0.5 isn't significant. Looking at the, go ahead. Oh, no, I'm just eyeballing it. We can go look at the significance over here in the output. Estimates, here are the p-values right here. And so we can see not significant. 3 stars means it's significant at the 0.001 level. If you want to see more decimals at the top here, you can push it up to... Oh, just look at amplitudes, and I know our sample size. And so, roughly speaking, anything above 0.14, 0.14 is probably closer to it. Yeah, is going to be significant. That's not a guaranteed threshold. That's just my guessing math. But that's probably about right. The negative 0.05, negative 0.08, yeah, they're not different from 0, is what that says. Yeah. Again, you can see more decimals. If you want to know how significant these are, you can push it out to as many decimals as you want. Yikes. These are super significant, these 3 stars, because that means it's still significant at the 0.0000013 decimals 1 level. So even the physicist would accept this. There we go. 3, oop, that's 4. Let's go to 3 decimals because that makes life a little easier. Anyway, so we have some significance. I'm not going to treat it right now, except I'm going to look at age, gender, and education. These guys right here are controls. And it turns out nothing is significant except possibly education on information acquisition. Sort of makes sense. That's at the 90% confidence level, 0.071 p-value. We haven't tested yet for one group versus another group. So this is, again, just preliminary looking at it, seeing if things work out. We're not testing any theory right now. We're just looking at it. Please, yes.
So if you run your model the first time, I don't have moderators.
Correct. Yep, controls, no moderators.
So you get just awful statistics. What is your next course?
All right, so the question is, I run the initial model, which is not testing any theory, and it's just awful. What then? Well, don't despair, because this isn't testing any theory. We're actually going to split the data into our groups and test one versus the other. And it turns out if you have, for one group, a negative effect and for another group a positive effect, then those neutralize each other when they're all together, and you can have no effect. And so some of these where we see no effect might actually be significant for one group or for the other. So don't despair yet. This is really just eyeballing it, seeing if things... Yeah, plenty of time to despair. So, at this point, I would also go look at model fit just because I'm curious and see that our model fit is pretty awful. Look at that, 18, 770. These are just awful numbers. And if I want to know why, I go to modification indices. Turns out E1 and E2, oh, E3 and E4, 173. What's that? E3 and E4, decision quality, information acquisition. From the get-go, we have known that this was going to be a problem, that there is a discriminant validity issue between these two. They are highly correlated, that they might be even part of the same factor of system success. So what do you do at this point? Nothing. Not yet, because we're not testing any theory. If we go and test our 2 separate groups and we realize there's still no way these guys are going to be separated, we might create a second order factor for them and just predict that one second order factor instead of trying to predict them separately. So we'll see how that rolls. Another sort of cheating way you could do it is you could add a regression line between information acquisition and decision quality, because really the better information you're able to get and the more information you're able to get, probably the better decisions you're able to make. So that makes sense theoretically. You didn't theorize about that. And also, if you do that, it's going to swamp out a lot of other effects. Let me show you just for an example. Proceed. Up arrow. Our R-square on decision quality gets a lot stronger, but some of the effects, for example, from enjoyment, look at the effect now on decision quality. Negative 0.03 no longer exists. If I get rid of that line that we just added, run it again, proceed, up arrow, 0.18. So now there's an issue here. This goes back to model fit and proceeding with poor model fit. This model says enjoyment predicts decision quality. Is it true? Yes, when not accounting for the effect information quality has on decision quality. So that's tricky. So what would you do? Most likely scenario, you're either going to draw that line from information acquisition and decision quality, and you're going to have to adjust some things in your paper accordingly, or you're going to create a second order variable, which is what I think I'd prefer to do. That way we don't dampen out all these other effects. Anyway, let's get to that when we have to get to that. Questions before I proceed to the slides? Okay.
James,
Yes.
At this stage, can you covariate errors?
So there's another option, a band-aid option, where, check it out, if I covary these two errors, right here, watch my model fit. I'm going to go proceed, show my model fit, much better, nearly 0.95, and see RMSDA, almost, not even close, but we're a lot closer than we were, right? And if I look at the up arrow, look, it's still 0.18. Whereas before, when I added the regression line, it messed things up. It dropped it down. What am I doing here? What I'm doing here is I'm saying we expect there to be a systematic, non-theoretical correlation between the error of the information acquisition and decision quality. Therefore, we want to account for that systematic, non-theoretical correlation that in order to enable us to continue to theorize about these other effects. That works when there is no theoretical justification for adding a regression line. The problem is information acquisition surely affects decision quality. And so I am, instead of fixing things, I am refusing to see what's staring me in the face. I am choosing to be blind to the real effects in the data. And so I would argue that this is probably not the best approach. Unless, of course, there is an atheoretical, there's no reason these two should be correlated, but turns out their wording is very similar or whatever, that sort of thing.
Did you have a different perspective if they were mediated as opposed to deviated?
So we know that E1 and E2 are also highly correlated. We saw that in modification indices. So the question is there a reason why usefulness and enjoyment should be related? The more useful something is, the more enjoyable it is. I don't know if that is, I don't know if maybe ceteris paribus, maybe. The more enjoyable something is, the more useful it is. Also, I don't know if that holds. So that might be a more likely case where we could covary the errors. I don't see a strong theoretical reason for including regression there. Yeah.
Even if in the modification indices say that you should covariate E1
Yeah, even if it says so.
Yeah.
Well, if it says so, that's what we're addressing. Because it says so, we would now consider whether there is just cause to covary the errors or to do some other action to address that modification it's suggesting. So the only two things we can do really are covariate the errors or add a regression line, or worst comes to worst, for mediators at least, put them into a second order construct. I don't believe enjoyment and usefulness are part of the same thing. I don't think they are a second order construct. These are two totally different things. Yeah.
When you showed your regression weights and lock it down, playful to enjoy loaded at a 0.51.
It was very strong, yeah.
Very strong, and you could argue that theoretically playful, the more playful you are or it is, the more you enjoy it.
Certainly.
You're not tempted to make those a second order construct.
No. So the question for remote folks, playful and enjoyment were strongly, there's a strong relationship between them, 0.51. At what point would I say, ooh, maybe these are the same thing? 0.51 is getting up there. I'd start thinking about that around 0.8. Yeah, saying, well, the only reason we're going to get a regression weight that high is because it's tautological. These are really part of the same thing.
The 0.51, and then the statistic I didn't recall seeing the CR, on the estimates for playful and enjoy were also very large. Just look at the output real quick.
In
On your standardized estimates, yeah, so,
the CR here, that's the critical ratio. Yeah. Yeah, okay, playful to enjoy is here. Critical ratio is 10. That's really high. Very significant. But again, until we start getting way, way up there, I'm not too concerned. These are the same thing. Yeah. Also, as I think about them theoretically and think about the items that we use to capture them, playfulness was definitely a different thing than enjoyment in the items in the survey. Cool. So at this point, I'm going to do nothing because we're not testing any theory. I'm going to start doing things when we start testing theory. Most likely scenario, I'm going to covariate E1 and E2 because that makes some sense. Most likely scenario, I'm going to combine information acquisition decision quality into a single second order latent factor. So, but for now, I'm just going to save it. And we're going to talk about some things. Okay. So we're testing mediation and moderation today, among other things. And these are different things, easy to confuse, super easy to confuse. Mediation is, depends on how you think about it and how you theorize about it, but it is sort of the stepping stone from the IV to the DV. It is also the transfer mechanism. So the reason for the effect of the IV on the DV is because the IV affects the mediator, and the mediator affects the DV. That's what mediation is. Moderation, on the other hand, is when some other variable changes the form of the relationship between the IV and the DV. So the IV doesn't affect the moderator. The moderator doesn't affect the DV. The moderator changes the way the IV affects the DV. And we'll see some examples of this. So, for example, here, curiosity, we're going to say increases system satisfaction. The more curious you are, the more satisfied you are when you use applications. And the reason for that is because when you're curious, you tend to engage in discovery activities. And it's that discovery that leads to satisfaction. So that's mediation. Whereas in the next one, same variables, curiosity increases your satisfaction with systems. And the more you engage in discovery, the stronger that relationship is. The less you engage in discovery, the weaker that relationship is. That's moderation. So mediation is a highly debated topic in the literature, and there's so many articles on it, and it's been decades we've been arguing about it, what it is, what kinds of mediation they are, how to test them, and school's still out regarding the best methods. And so I'm going to teach you my methods that are based on several different papers. But they're the ones that make sense to me. So again, Gospel according to St. James. Or just James, actually. Okay. There are three... Gotta be careful. There are three main logics, mediation logics I'm going to talk about, and we'll test today. One is the mediator is a necessary step. So X affects M, the mediator, which then affects Y. That is a necessary step mediation. There's also a very similar, it's an indirect effect only. So X affects M, but only through, or X affects Y, excuse me, only through the mediator. These are very similar. Number one assumes that there is no relationship between X and Y. That it's just that X affects M and M affects Y. Whereas the second one assumes there is a relationship, and that relationship is transferred through M, or it only occurs through M, which is also similar to 3, and that M is the reason for the effect of X on Y. They all sound exceptionally similar, and there's just little fine differences between them. So in this case, interest, if we were to take necessary step logic, interest increases engagement, which increases learning. The second one is interest affects learning through engagement and being engaged. And number 3 is interest affects learning because interest affects engagement, which affects learning. Again, subtle differences.
James,
And it all goes back to the way you argue it and theorize about it.
how would you distinguish the direct effects with mediation and indirect effects?
The direct effect here,
Mediation and not direct effects, so direct effects with mediation and indirect effects.
I don't think I understand the question. Are you talking about the direct effect between X and M and Y, or between X and Y?
So there are 3 tests we have to be with. The direct effects are basically X to Y.
Oh, okay. Yeah, that direct effect.
That's
Okay.
direct effects.
Yes.
But
We
direct
would.
effects with mediation is through M.
We
The
will.
indirect effect.
We.
Are you referring to full mediation, partial mediation, that kind of?
Correct.
Okay. We're gonna get that. It might be the next slide. Here we go. Next slide. Thank you.
So I'm looking for 2 and 3.
All right. Let's talk about each of these. So there are 3 different logics, but there are 4 different types. Hopefully this is good and confusing. There's full mediation. Now this phraseology, these labels, hark back to Barron and Kenny back in the 80s, who I think it's 1986, who wrote up something on full and partial mediation. And then more recently we've seen indirect mediation from Matthew and Taylor, I believe, and then competitive mediation from Zhao et al. 2010, I think. So I'm mixing multiple articles here to get all these labels. Full mediation is when you have an effect between X and Y, regardless of the mediator. Forget the mediator. Don't even stick the mediator in there. And there's a relationship between X and Y. But as soon as you throw the mediator in there, that relationship between X and Y is gone. It's completely non-significant. I think we might even see that between, if I push up on this, notice here this non-significant effect, playful to decision quality. I wonder if I got rid of enjoyment, would this be significant? If so, then we have full mediation going on here from playful, enjoy, decision quality. We'll see. Partial mediations, when you do the same thing, you test the X to Y relationship without the mediator, and it's significant. Then you stick the mediator in there, and the X to Y relationship is still significant, but it's much weaker. Whether that's less negative or less positive, it's just closer to 0. Indirect mediation is when there is no relationship between X and Y until you stick the mediator in there, and the only effect is through that mediator. So there's still no direct effect between X and Y. There's only an indirect effect through the mediator. The last one's...
Is there something in the real world that works like that?
Yeah, sure. In the real world, we might pretend, we'll have to pretend, this example here, that interest doesn't really affect learning. There's something there, right? We know interest affects learning, but it's only indirectly through being engaged or curious or discovering or something like that.
If you're just gonna do a regression and linear learning, you waste your relationship.
In indirect effects only, no. Yeah, there's too much noise. There's not enough information. And so it's only when we add the mediator that we are able to discover the true path, the indirect path, through which interest affects learning. Now, yes?
Could we create a model with the data that we're studying?
Yeah, sure. Yeah, let's go here.
Yeah.
Examples here. We're going to hopefully see all types of mediation, I hope. But in this case, we might say, again, the playfulness, enjoyment, and decision quality. You might think playfulness has some sort of effect on decision quality. There's got to be something there. But we don't know how it's happening. Turns out it's happening through enjoyment. As you're playful, you enjoy using the system more. As you enjoy it, yeah, you make better decisions. But without that mediator, we couldn't have really known, couldn't have pinned down how playfulness affects decision quality. And even after we stick the mediator in there, that direct effect's not significant. It's only through the mediator that we see that indirect effect. We're going to do several of these. No, several. We're going to test them. And the last one, competitive. This is really bizarre stuff. It's only come up recently. This is when you don't have a direct effect between X and Y. But you throw the mediator in there, and then all of a sudden the direct effect is significant, which is really weird, because you'd think that, no, the mediator should be sucking out that variation, that variance explained, I should say, and there should never be a more significant effect after adding a mediator. Well, it turns out this happens when the mediator, let's go back to our example, when the independent variable has dual effects on the dependent variable. Let's say, for example, playfulness can lead to both better and worse decisions. It sort of depends on some stuff. And so because it leads to better and worse decisions, taken together, they neutralize each other, and you observe no effect. Now, when you throw the mediator in there of enjoyment, enjoyment explains the way you make good decisions out of playfulness. And the only variance not explained is how you make bad decisions out of playfulness. And so once you've extracted that positive variance explained, the negative variance explained is now allowed to freely be itself and reveal itself. And so you'll see a strong, significant negative effect as the direct effect, and you see a positive indirect effect through the mediator. We did a really cool study. Some of you might know Deirdre Dixon. She studies in extremist situations, life or death situations in the military. And we were trying to figure out what's going to lead to better outcomes in extreme life or death situations. And we thought for sure better training would lead to better outcomes. But we ran the model and it was completely non-significant. We had fabulous data and we saw nothing, and we were so upset. And so we were messing around with the mediators. We came up with a mediator called something like inner virtue. It's this desire to be selfless and to act for the benefit of others over yourself, and to be a protector rather than sort of a protector of oneself. And it turns out all the training, if the training leads to this selfless virtue, that leads very positively to better outcomes in extreme life or death situations. But then the negative effect remains, where if all the training leads you to be rigid in what you do and doesn't make you a virtuous, selfless person, then it has a negative effect on outcomes. It's a pretty cool finding. Go ahead.
You were starting first. Could you also explain that outcome with a moderator?
Okay, so what if we took the training to positive outcomes and said, instead of a mediator, instead of it creating selflessness and virtue and all that, what if we said, in as much as training, in as much as you have virtue, the effect on from training to outcomes is positive. In as much as you don't have virtue, the effect from training to outcomes is negative. We would probably have seen a similar effect, yes. But theoretically, we anticipated training to improve your virtue. And that's why we modeled as a mediator, because we thought there was actually a causal effect from IB to mediator. Whereas if there was no effect from IB to mediator, like what if we were saying, well, it's only in as much as you are old. Well, training has no effect on your age, except maybe this training has aged all of you guys quite a bit. I don't know. But no real effect on age. And so age could never have been a mediator, because you can't cause age, right? Yeah, how it occurs.
Okay, so my question is, when you publish competitive mediation, do you typically need to find the mediator for both situations?
Oh, good question. No. Usually when you're publishing competitive mediation, which is rarely done, usually when people see this, they're like, oh no, my data's broken, I can't publish this. Okay, and people give up on it because they don't know what it is. Oh, I'm so sorry. Now you have it. You go back to that data. No, so people usually give up on it. So there's not a lot out there on that. If you want to see something on competitive mediation, look at ZAO. I wonder if it's in there. ZHAO or something like that. Let's see. Rev. Let me get it for you. I'll stick it in. ZAO. Did I spell the same way both times? Ah, yeah. Reconsidering. Nope, that didn't do it. Baron.
When is this publication from? It must be relatively recent. We don't talk about this.
It is fairly recent. Let me show you. Oh, not that one. Okay. Here we go. Scholar, reconsidering Baron and Kenny. Here it is. Zhao et al. 2010, JSTOR, Journal of Consumer Research. That one. Let me just stick it in that folder just so everybody has it. Full text online. Probably violating some sort of license agreement by sticking it in Dropbox folder. Sorry. I have a copy somewhere that's a lot smaller. Oh well. Recent places. Oh, I know where it is. And it's a smaller file. It's in here. Here. Open Google Drive. Here. And here. Here it is. Okay. Not move. I don't want to move it. I want to copy it. Here we go. There it is. Okay. So it's the type 4 mediation, I think on page 204, something like that. They're, I think, the first who have come out and talked about it directly, that this is competitive mediation. Very cool stuff, but usually you don't theorize it. So to get back to answering your question, do you have to have a mediator for both? And the answer is no, because usually you don't anticipate it. Usually you don't theorize that I'm going to have competitive mediation, although people might start doing that. That'd be very cool. Usually you discover it by accident.
So it would always be usually a post-hoc test.
Yeah, correct.
Does AMOS do anything for post-hoc? Or is it all considered post-hoc?
Depends on how you use the term post-hoc. If you do an analysis after you've tested your theory, you could call that post-hoc. There are specific post-hoc tests in, not in AMOS, but in SPSS. But no, AMOS doesn't have any specific post-hoc tests that I know about. Okay, so there are 4 different kinds. We are going to hopefully see some of them. All of them would be great, but I don't know if we will. And now the approach. I have a 3-step approach to this. My recommendation is you always run a mediated model without the mediators first. You got to see if there was ever a direct effect between X and Y without the mediators. Otherwise, you don't know if there was, and you don't know if it's indirect or full or partial or what. You could only ever claim indirect effects. So you run it, see if it's significant. Then you would bootstrap, which I'll show you how to do. You'd bootstrap the model with mediators in there and see first what happens to that direct effect after you added the mediators in there. Did it drop completely? Did it just drop an amplitude but it's still significant? And then the bootstrap allows you to estimate the significance of the indirect effect, which is cool. So it actually gives you an estimate for that indirect effect, which is really just the two effects here. It's really just x to m and m to y multiplied. But it gives you a p-value for it as well. And the last thing is, if you have multiple mediators, which we do, the indirect effect is insufficient. The indirect effect is going to test. Let me go to our real model. The indirect effect is going to test the effect of atypical use on information acquisition through all indirect paths, which in this case is through usefulness and through enjoyment. And so you can't test with a bootstrap the indirect effect of x to m to y when you have two mediators. You can't. It won't do it. Huh? You could either trim out a path, but as I was talking with Bill earlier, every time you trim anything or add anything, because this is an interrelated network of effects, they're all interdependent. As soon as you trim out something, you've changed your model, and so you're not getting the most accurate estimate. And so instead of trimming, which is what I think I taught last year at the boot camp, I would do a Sobel test. A Sobel test allows you to test the effect of x through m on y, regardless of the number of mediators. The one assumption, two assumptions of this are you should have roughly normally distributed variables, which we do. We checked those way back when. And sample size, it's inflated by sample size. That can't be right. No, I think that was the only assumption. It's for normally distributed variables. So we're good on that front anyway. So let's do it. Let me just make sure I haven't missed anything crucial. Yep, so we're going to do it. We're going to test this stuff. Here's our hypothesis we're going to test. Usefulness mediates the relationship between atypical use and decision quality. So that's atypical use, usefulness, decision quality. Those three. Let's go test that. Saving this, I'm going to now save as something else, maybe as a path H1. Is it H1A? H1A. I would just say H1. Okay. Do I get rid of everything that's not included in H1? No, because I want to account for all effects while testing this hypothesis. Do I need interactions in here while testing it? No, they're part of a different part of my theory. Do I need the multigroup moderators in here while testing that mediation? No, they're part of a different part of my theory, unless I'm testing moderated mediation.
At this point, do you need all for the three XM and Y that you're investigating here? Do you need to have drawn direct and indirect effects? In other words, you can't draw a full mediation.
For now, we're going to actually drop the mediators and test just the direct effects. Then we're going to throw them in, keep the direct effects, and then if we want, we can drop the non-significant direct effects at that point, because we're theorizing mediation anyway, so we can drop those direct effects. If they are significant, we should retain them, because otherwise we'll have terrible model fit, and we're not accounting for major relationships that should affect our model. So we'll do that. Yeah?
The capstone model that we were given doesn't have direct effects drawn in.
Neither does this one. But it's assumed that you're testing mediation. And so at that point, I'm going to get rid of these mediators and test just those direct effects. Now this also goes, you can fall back on what any of your advisors have said. If you don't want to do all these steps, you can just do a bootstrap and see if there's indirect effects. You can do that. Just from my perspective, you're losing a lot of information when you don't test with and without, and when you don't isolate the mediated effect. So that's the James camp of mediation. Yes?
So one thing that I've seen recently in papers is that people will they'll do their structural equation modeling, so they'll do their CFA, and then they go to their path model, and then instead that's where they stop, and then they start testing the path and process. Are you familiar with process?
Yeah, I'm familiar with process.
So they'll test the mediation path and
Yes. So let me talk about process for a bit. So process is a really cool set of macros that is it Preacher, I think?
Yeah.
Preacher and Hayes have collaborated on. And so they're a plug-in for SPSS. I've never used them. I've known a lot of people who have used them and have talked to me about it. It allows you to estimate indirect effects through multiple mediators and isolate the effect through a single mediator simultaneously. So it does essentially what we're doing in one step. You just have to plug in. You have to get that plug-in and learn how to use it.
Right. So what they're doing in the papers I've seen, is they'll have multiple dependent variables, but when they put it in process, they'll just use, so they'll do, for example, what we were talking about, so they'll use computer use, atypical use, usefulness, and then they'll do each one individually. Separately? Yeah.
Okay. Kosher? Not terribly kosher because that's saying we don't care about the potential confounding effects of comprehensive use and playfulness and enjoyment and decision quality. And since SEM is an interrelated network of interdependent effects, you may be inflating effects that you've isolated. And that's why I tested all together in Amos.
Right, okay. That's what I thought.
Yeah.
3 papers that are published that way.
I'm always amazed at what's published. It's really, yes, it's amazing what's published in good journals. It depends on your editor and your review team if they know anything about SEM. And then people start citing those papers for their methods, even though they were stronger in theory than in methods, and then you get wicked traditions. And anyway, yeah. Okay. One can only do so much. Okay. Here we go. Let's test that theory. It was playfulness to usefulness to decision quality. Actually, we're going to take a quick break. Sorry I need to take it. My heart keeps skipping. All right, so we're going to take a 5-minute break. I'm going to lay down for a sec.
So remember my really messy model? Yes. Okay, so here's all of your variables. Right. Okay. So, and that one, that's over all of those, right? Okay. So then delete all those correlations. Here. Yeah.
Did you care for a snack or a drink?
I know that you do. Yes, fine.
Yeah, so when you're in this kind of time, you can't like model it all.
Don't necessarily say all of this.
Okay, so then try your, no. That's fine.
No, we're, well, Laura, actually.
Right, so if you put in each big one, right, big, huge, like, construct, right, you would. Yeah.
Oh, that's where I got stuck. This is where I.
So she's doing something different. She's doing the CFA. You did the CFA done, right? Okay, so that's that. Because it's by and then you're going to constrain put error on because it's the arrow going into it.
But that's not bad. Not too bad, not too much.
Okay, and then go from there.
This is what I say, she has my time off. Because when you start to do moderation, you're gonna escalate the model. You're gonna put things in that don't stay in. You're gonna take things out that don't stay out. So if this is, it's a, and things we can theoretically, yeah, so this is your base camp. And you're going to explore up one path, and you're going to explore up another path, and you're going to test for evolution, moderation, and you're going to whatever you want. But yeah, this is I think our final SEM.
Yeah.
Model. Now, as a say that, and as a practice.
Do you guys have any questions? Let's see if I can.
So,
This is my second.
I just broke stuff. I take my model. Sorry, for reference. Here's one of the motions I want to see. Find your way back. So there's this tension. That's right. Yeah, and look at it. You what? And I was giving you questions. You need this. And what they if you look
sounds like a bunch of control mechanisms for
One of them, oh, I did, it's very important. And I want to go back to my.
Yes, the retention, yeah. So you have one target, you also really
What there's some.
Yeah.
They're gonna try out.
So
So I wanted to.
because we didn't use binary, you could do it in
Yes. So
All right, we're going to get started again. I'm not feeling fabulous, but we'll see how it goes. Oh, thank you. I look fabulous. All right. Bill always knows the right thing to say. Said no one ever. I mean, all right. I think we're about to test that that hypothesis, H1A. Usefulness mediates, this one, usefulness mediates the relationship between atypical use and decision quality. Here's atypical use, usefulness, and decision quality. So that indirect path. Okay, so to test this, we first want to remove the mediator. You can remove both at the same time if you want. I'm just going to remove the one. I'm going to remove both, actually. Excuse me. I'm going to remove both so I don't have an indirect effect going on for anything. So I've already saved this. Let me save as path 1. I did. Good. We've saved that as a new model. I'm going to take out usefulness completely and its error. I'm going to take out enjoyment, so I have no mediators anymore. I still have the controls because I assume my hypothesis is controlling for these effects. So you got to keep those in. We're going to run this, proceed, up arrow, and again that was atypical use down to decision quality, right? Decision quality. There's a 0.13. We don't know if that's significant. That's really borderline. So I'm going to get out a little piece of paper here. I'm going to write up some effects. So from ATIP to decision quality, we have ATIP to decision quality. It is significant at the 0.05 level, at 0.026, and the standardized regression weight, not this one, the standardized regression weight is 0.128. I'm going to write that in there. 0.128, which is significant at the 0.05 level. I'm going to put a single star to indicate 0.05. Let me zoom in there. There we go. So that's our without mediator. Let's test it. Yes?
So let's say, for example, going back to your model,
Mm-hmm.
let's say, for example, that there was a variable in front of playfulness, so the items were correlated. There's just one variable in front of playfulness.
Uh-huh.
We weren't expecting,
Let's go back to the model here.
we weren't really expecting mediation to exist there so much. Should we include that in the model?
If we didn't expect mediation,
Yeah, but we should technically expect mediation if there's a variable in front of playfulness, right?
oh, no. If I understand the question correctly, what if we have a model that looks like this, but we're not actually hypothesizing mediation? We don't think that usefulness or enjoyment is a transfer mechanism or is a stepping stone or a gateway of any sort. We just think that playfulness affects enjoyment. And also, separately, enjoyment affects decision quality.
Right.
Yeah, we don't have to test mediation.
Okay, so let's say, for example, atypical use.
Uh-huh.
There's a variable in front of there.
Here's a variable over here,
No, on the other side.
this side.
Yeah.
Okay?
And it was going into atypical use.
Yep.
But we're expecting mediation with enjoyment. Do we include the variable up there?
Okay, so what if you have another fourth column here?
Step one.
Yep. If you have another fourth column of variables here, there's something before atypical use. Go in here, and now I'm theorizing atypical use as being the effect of atypical use on decision quality is being mediated by enjoyment, regardless of whatever's over here, right? Would I include that variable over here? Yes. Yes, I would.
So if you did that, would atypical use be enough to
Atypical use is only mediator if you theorize it as a mediator. Yeah. Same with usefulness and enjoyment. They don't have to be mediators. It's only if you theorize it that way. Yeah. Now, I gotta warn you. I just reviewed a paper where they tested a model very similar to this, and they saw there was a significant effect here, a significant effect here. They didn't hypothesize mediation. I got to the discussion section, and one of their main contributions was we found mediation between these variables. And I had to write them back and say, you didn't find mediation, you didn't test mediation, you didn't theorize mediation. So if you're going to claim that this is a major contribution, you actually have to theorize about it and test it. So just because you have a model like this doesn't mean you have mediation. You have to actually explicitly theorize about it, create a hypothesis, and then test that hypothesis. Okay, so we've recorded that effect. Atypical use to decision quality, 0.13, moderately significant, 0.05 level, yes?
So if you have a model like that you're not theorizing mediation,
Uh-huh.
would you just report fit indices then?
You always report model fit, yes. But then you would only report the direct effects between IV and quote-unquote mediators. Not a mediator, but yeah, you just report all those direct effects. Yep. Yep. Yeah.
If you don't, direct effects, if you don't use controls, you're effectively seeing a stronger, you should see a stronger effect.
Possibly. Possibly. Unless, no, nothing, no. The question, remote folks, is if I throw controls in there, is it going to weaken my effects from independent variables? Oftentimes it will. Sometimes the answer is no. Like these guys, they have no real effect. And so, no, it's not going to hurt anything. It could increase my R-square. But this is something we'll talk about later. But if you have a big control, organizational studies on performance, particularly if you're looking at financial performance, if you see a study that doesn't control for organization size, then there's a big issue, because if you throw organizational size in here and predict performance with it, that's going to explain a ton of the variance in performance, because size and performance are highly correlated when you're talking about financial performance. And so if you claim that some IV has some effect on performance, but you're not controlling for size, that IV might have some large impact. But as soon as you control for size, that impact's going to really reduce. Yeah. In this case, we don't have that issue. Okay. Now let's go back to the model. Let me save this. Let's go back to the model with the mediators. So that was path initial. Here it is. Just go back to that saved model. Run it again. Proceed. Up arrow. We see atypical use to decision quality, 0.12. Not really changed, huh? Let's see if it's significant. Estimates. Let's see. Atypical use to decision quality. Where'd you go? Where'd you go? Here it is, down here. 0.018. Still significant. Okay, so let me write that in there, and the effect is, let me go down to the standardized effect. Atypical use decision quality is 0.116. See, with mediator is 0.116, and it is still significant. So at this point, I can say we don't have full mediation for sure. We don't even have partial mediation. But we might have indirect. Correct. We might have indirect. So let's go check. Indirect? Question mark? Let's run a boots. Yeah, we'll have to do. This is sort of a not a great way. We're gonna cancel. I'm gonna go to analysis properties. Go to the bootstrap tab. We're going to perform a bootstrap. Now, since Amos was made back in, obviously, the early 90s, it has only 200 resamples on the bootstrap because computers were not powerful back then. I'm going to add a 0 So we have 2,000 because computers are powerful now. We're going to use bias-corrected confidence intervals. This corrects for some of the bias introduced, the inflating that's introduced by bootstrapping so many times. So those are two things I'll do. I can shove it to 95% if we want. I'm going to keep it at 90 because I'm happy with a 90% confidence interval on indirect effects. Close that and run it. Proceed. And you'll go to the estimates. Oh, bother. Sorry, I missed a step. I'm sorry. In the analysis properties, in the output, you need to do indirect, direct, and total effects in the output tab. Check that box. This will give us the bootstrapped indirect effect if we're bootstrapped. So grab that indirect, direct, and total effects. And we'll run it. Proceed. Go to estimates, and now you'll see you have a new thing called matrices in the estimates. And in there we have total effects, direct effects, indirect effects. So we're going to look at the standardized indirect effect, which is right here. Again, estimates, matrices, standardized indirect effects. We want to know from atypical use to decision quality, what is the effect? Oops. The indirect effect is 0.011. Not powerful. That's the standardized regression weight. If we want to see if that is significant, we'd go down to the bottom here. They're estimated bootstraps. Open up all the way down to the bottom, this two-tailed significance. The very bottom of estimates here. We go look at atypical use. The decision quality, that is the p-value for the indirect effect. Not significant. At this point, I don't need to do a Sobel test. We know there is no significant indirect effect. Even though this indirect effect does take into account both usefulness and enjoyment. It's not even mediated through both, so it's definitely not mediated through one. So that one is finished. The indirect effect is 0.011 and not significant. So we do not have mediation through the H1. H1 is not supported. No evidence to reject the null hypothesis. We're going to do another one because it would help. Let's do one more. H1b. Usefulness, again, mediates the positive relationship between playfulness and information acquisition. Playfulness, usefulness, information acquisition. Playfulness, I should move these around. Usefulness, information acquisition. Okay, let's go back. Let me save this one. Let's go back to that path H1 model here. Excuse me. We're just going to run it. Look at that effect. Playfulness to information acquisition. Ooh, very strong effect, 0.37. Let's go look at the estimate. Estimates. Playfulness to information acquisition. Very significant. I guess very is the incorrect term there. It's just definitely significant. Playful to info ac is 0. Information playful 0.372. Definitely significant at the 99.9% confidence level. Let's go run that with the mediators. So go back to the mediated model. Run it again. Up arrow. Playfulness to information acquisition, 0.12. That really dropped a lot. I don't know if it's even significant anymore. So go look at that. Estimates. The p-value, information acquisition, no, I'm sorry, playfulness to information acquisition is right here. Still significant, but much less so. Not at the higher confidence level. So the estimate, again, playfulness to information acquisition, playfulness, here it is, 0.124. So go over here with mediator, 0.124. significant only at the 95% confidence level. Indirect, let's see. We ran it already, so we can just look at that output. You go to estimates, matrices, standardized indirect effects. The standardized indirect effect currently stands, that can't be right, oh, playfulness, sorry, stands at 0.262. Problem though, this is also going through enjoyment. So what we can do, instead of using this number, because this number is not accurate, we can multiply these indirect paths. Let's see, from playfulness to usefulness, 0.27, times usefulness to information acquisition is 0.43. So 0.27 times 0.43, our true indirect effect is 0.1161. So I can throw that in there, 0.116. But we don't know if that's significant because the p-value it gives us from the bootstrap is also through enjoyment as well. So in order to get the real p-value, we got to go do a Sobel test. So let's go do that. Where do I find a Sobel test? Google it. There we go. Sobel test calculator. Free Sobel test calculator from Daniel Soper. Really nice guy. He's out at Fullerton. All right. So this Sobel test calculator, which is the, I think, the second hit, the first real hit on Google when you type Sobel test calculator, allows you to enter the first number, which was for us from playfulness to usefulness, 0.27. 27. And then B is from mediator to dependent variable, so 0.43. And then the standard error, I got to show you where to get that. Standard error of that first path. In your output, excuse me, in your output, if you go to your regression weights table and look at, for this first one, A, for us is playfulness to usefulness. Here's playful to useful. The SE column is standard error. So that's 0.055. And then for that next path, from usefulness to information acquisition, it's 0.039. So not very much error. We hit calculate. It gives us the p-values, two-tailed p-value. This is definitely a significant indirect effect. That's just read as a regular old p-value. Less than 0.05 is significant. We are less than 0.001 at this point. So that indirect effect is significant, star, 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 at the 0.001 level, 99.9% confidence. And so we would say H1B is supported. Here's the evidence. The Sobel test statistic tells you if the indirect effect, the stepping stone effect, is significant based on the amount of error and the amplitude of the regression weights. It is, yeah, that two-tailed probability is a, oh no, so this Sobel test statistic is like a critical ratio. So anything above 1.96 would be considered significant at the 95% confidence level. Yeah, you could report the Sobel, or you could report the critical ratio as 4.48, and then the p-value for that two-tailed p-value is less than 0.001. Yes. Yes. Go ahead.
This path is the partial mediation.
So yes, good question. So what kind of mediation do we have? The direct effect was very significant, very strong before we added the mediator. We added the mediator, it dropped substantially and is no longer, it is much lower in significance. It's at the 95% confidence level instead of the 99.99999% confidence level. And so since we did observe that there is a significant indirect effect, then we can say with confidence that we have partial mediation, because the direct effect dropped is still significant and the indirect effect is significant. So we have partial mediation. This follows on the slide, this one right here. was significant. The direct effect x to y was significant before, still significant, but less so now. And then the indirect effect is also significant. Therefore, we have partial mediation. Yes. Yeah, we could have, but we definitely didn't need to, because the question was for the first path H1A that we tested, we could have done the Sobel test as well and gotten a p-value for that. And if I were reporting it, yeah, I guess we should, so we could report the p-value. But we knew just right off the bat, if it's not significant through both mediators, it's definitely not significant through one mediator. Yeah.
The Sobel test replaces a method that I saw somewhere, where you delete a line one at a time. And
yeah, so in previous years and in a couple videos on YouTube, I think, I advocate in absence of better procedures at the time, at least lack of knowledge on my part, I think, at the time, I advocated dropping a path so you did isolate the indirect effect. But again, this manipulates the model, which I don't like. And so I was never happy with that approach. It was just the closest we could get with my knowledge at the time. But you can see now, I hope, that by using all three of these steps, you're both isolating the indirect effect and you're testing its exact p-value, which is great, for just that indirect effect without manipulating your model at all. Yeah. Yes?
So, so I've read different things. So Hayes is bootstrapping. You're more inclined to find significance with mediation as you give a smaller sample size. And the Sobel test is more conservative. What do you recommend using?
You know, I haven't heard that. Definitely could be true. I just haven't heard that. So you're saying with the Hayes process procedure, you're more likely to...
No, I'm sorry, the bootstrapping. So bootstrapping your confidence interval is a little bit more liberal than I've heard. And the Sobel is a little more conservative.
So the comment for Rumovokes is that possibly bootstrapping is more liberal, or no, more...
Yeah, it's a little bit more liberal. Just
liberal.
able to use a little bit smaller sample size.
Because it allows you to use smaller sample size because you're bootstrapping.
Right.
Whereas the Sobel test is possibly more conservative. Yeah. Right, except we use the bias-corrected confidence intervals, which helps. And so, yeah, I have read that actually. And the bias correction in Amos allows us to offset that inflation due to bootstrapping. So as long as you're using the bias corrected, you're okay.
Okay. So just the first study with the bootstrapping, that should be fine.
If you have one mediator, just bootstrapping is fine.
Okay,
if you have
multiple.
Yeah, the problem is if you have multiple indirect paths from the IB to the DB. So the bootstrapping estimates all of those simultaneously and says, oh, the indirect effect is, but it's saying the indirect effect from here to here to here and here to here to here at the same time, that total indirect effect.
So if I were to delete one of my mediators and use the bootstrapping approach?
That would work. So the question is, can I just delete one of my mediators and run the bootstrap? Yes, but you are now estimating that mediation while not accounting for potential confounds of the other mediator. Yes. Yeah. So this is, as far as I know, the only approach where you can have multiple mediators and isolate the indirect effects and get a p-value for it.
Okay. And then my other question was, when you use Sobel's test, oftentimes we test the direct path, and then we test path A. And so why do we not delete our DBs and just use the mediator as the DB when we test the path A?
Because we're doing it while accounting for the effect of the mediator on the DB. We want to test the full model. Let me address an issue, hopefully a higher issue that will address this lower issue. When we create these models, we are creating a little piece of reality as we see it. That's our theory, right? This is an approximation of truth, our model. And every time we remove a variable, we're removing one bit of a lens, one part of the window into truth, our quote-unquote truth. And so we're saying reality exists while accounting for all of these effects. But as we remove a variable or remove a path, we are willingly narrowing our window into reality. So by not accounting for those effects.
Right. Okay.
That's my philosophy.
So this is the only way that we currently know how to account for rule mediation.
As far as I know.
Right.
Yeah.
Okay. I understand that.
So there are plenty of papers I haven't read and books I haven't read.
Right. Yeah.
Because I hate reading. But yes.
And just so I'm clear, because you're not removing paths and iterating, you can take this result for multiple mediations and put them into the SOAP test kind of without rerunning it. Just put the new factors in and come up with accurate mediation tests for all the mediation combinations that you've got shown.
Question is, can I just run the Sobel on this model for every possible mediation?
Well, you've run this model.
Mm-hmm.
You've taken statistics from it and put into the Sobel test for the focus mediation that you were trying to get an answer. Here you've got a couple mediations. So if you wanted to go and take comp use, usefulness, and info acquisition, you could go take those stats, go back to the Sobel statistic utility, plug them in just as they live now, just as they report or estimate now, and you could effectively estimate that.
Yes. So yeah, the real way I'd go about this if I were testing my grand theory is I would run the unmediated model and get every single effect while I'm there. I'm not going to go back and forth on each hypothesis. I'm going to grab all the effects, and then I'm going to run this model and do all the Sobel tests and all the bootstrapping and grab all those effects. Then I'm going to throw them all together and see what kind of mediation I have everywhere. Yeah. I want to re-emphasize the procedure for getting this indirect value. This was not reported anywhere. So just to reiterate, the way I got this indirect effect was by multiplying the A and B paths. So 0.27 by 0.43. That's how I came up with that 0.116 indirect effect.
Right, and that is the Sobel test, right?
Unfortunately, he doesn't report it. Where's the indirect effect? Yeah, it'd be real great. No, this is a critical ratio. Yeah. It'd be nice if you reported that.
It was kind of lame to have to pull out a calculator with all this.
Yeah, fancy stuff going on.
So the indirect effect is A, half A times half B, right?
Yep,
Okay.
correct. A times B. Yeah, Sobel only tells you if it's significant and to what extent. It'd be really nice, Daniel, if you're listening, not that you would be, but to add another little row here. Has the indirect effect. That'd be great. Maybe I'll email him. All right.
See the inputs of those?
Yeah, the inputs were 0.27 right here
And that's put in the Sobel.
and 0.43. Yep. So you could go to the Sobel test and grab it here.
He is calculating it, not
Reporting it.
Yeah.
And just for clarity, for simplicity, perhaps, when you load the Sobel test, you multiply those two, A and B, right there, and you'll get your indirect effect.
right.
Correct. Yeah, you could have just multiplied A and B here.
Calculate it, but it's like the standard error being squared over A squared or something.
Yeah, stuff like that. There's a lot of stuff going on in the background.
Yeah,
Yeah, which is why I would prefer to use his calculator than manually calculate that.
right. Okay.
Okay. Yay.
So, but we are just keeping we're just using that from the entire path, so we find point A and point B, right?
I don't think I understand the question.
So, we're not deleting any path.
Yeah, we're not deleting any paths as we test. Yep. Okay, that's mediation. We could go do a bunch more, but I think that sort of covers the idea. You now have the tools to go and figure out if you have whatever kind of mediation. That's great. I hope you don't mind. I want to take another 5-minute break real quick. Just a nice short one before we move on to moderation. I'm going to also check on the Hangouts people. Today's stop time, I was hoping noon. We'll see how far. I'm guessing we'll have a little bit after noon we'll need to cover. Honey, I know you need to go, so it'll be on the videos. But probably we'll have a few things after lunch. And for lunch today, I'm going to go to the Museum of Art. And I'd love it if some of you came with me and I can show you the museum and maybe walk you around campus. It's gorgeous. Ouch. All right, remote folks. Let's see. My data has been imputing for 10 minutes. Oh, no, it imputed. Marcia, let's see. Ouch. Ouch. James, could you please show us what a model that includes a second order construct looks like? Oh, yeah. Yeah, Marcia, I'll do that. Yes, definitely, after the break. Remind me if I don't, but I should. Z Milagros says, can we do mediation with hybrid path and not just imputed variables? Yes, it's the exact same process, Milagros. Exact same process. It's just you have latent variables. So there's literally zero difference while doing it, except it's bigger. Okay. Any other questions? Marcia, you asked also about your imputing. Did you get that to work? Okay, good. Yeah, really, it looks like it's processing forever, but it processes right away, and then it just says something was created. You close it, and it's still open. So it should process immediately. All right, I need to maybe take a break, lay down for a sec. Oh.
But you can go right through here and test your mediation, right? So here, from the test I put in SEMHO, right here, I put in all the numbers, a period of time. Yeah, so see, right in here, you can see for example. I put it in here, the full way in there, maybe there, because this change comes out, you're going to hypothesize full mediation. You have to disprove the question, right? You got to it's either not. So here, I would say, look, this is
Yeah. Just one meeting, that's very tough. When there's only one mediator,
Well,
it's like you're going to test it separate. But the first one we tested it together because there's just one mediator. Oh, that's what I thought. If there are two, but we didn't emphasize that there was a mediator for the first time.
yes.
I'm sorry.
No, my question was, what did you find that the second time? Or you know that this time, what did you do? The
SEM playlist, SEM series.
It's what you want me to do.
So now,
Usefulness mediates
Serious. If you see it there once, there
So the first one was the second was
no, I know. Why do you
Chanting bubble, yeah.
yeah. Because
Background, the psychology, I think you could be at the intellectual level if you want.
I mean, you should take it, but not as you might think it will talk to the next one.
Yeah, sure.
But yours is the same way. It's the
you'll be out. Yeah, indeed.
Well, so much for that's okay. All right. So you would know, there's the indirect and the direct with so we know direct without that. Direct with this one right here. That's the direct with indirect only for this one. This and this, yeah. For this and for this. So this will be because most likely because now it accounts for some of the and some of the
right? That's
correlated out here is actually.
But I don't see a star by it. It just says 0.05. Is that the p-value? I'm assuming that's the p-value, right? And what do I use for my code? Like use you know, so I got
I don't understand.
So obviously you can have one here, and then you know what you do.
Really, here by here.
Direct. You see, no action. You do right now the numbers.
So I break those down because that's when you're, so that would be what you do, I think, when you have two mediators, which you can, you know, if you want to do football. But I'd rather do draft, I think, when I'm one mediator, and I think it's more powerful.
Almost everything that I
Like, I'm not exactly sure. Yeah, right.
I just covered a couple times.
Yeah, I'm not sure. So I have here the regression rate.
So right now, I'm going to use those skips that pictures into the
Yeah, very well made.
And I do the same thing as the substance. This is my schedule.
Oh, here.
Because the only bootstrapping gives us is the comments are over monitor.
That's the upper bound, right? And that's the lower bound. And that's telling me that my result is significant, so it's in the bound.
Right now.
Statistics. Because you know, I'm going to space these into Word and they're too long. So
Okay, we're going to get started again. I want to make a clarification. I love doing this boot camp because I learn a lot as we go through. As we get started, I'm going to answer Milagros' question. She asks, is it necessary to use control variables for mediation even if we don't theorize it? The answer is no. If you don't theorize about controls, don't throw them in. The question is, when should you theorize about controls? And we'll talk about that later in the day, but as a short answer, anytime there could be a potential confound, something else that explains the variance in your dependent variable, other than what you've already theorized, well, then you need to include a control so you can say that your IV really does have an effect on your DV, even when accounting for that control. Cool. There's another point of clarification I need to make. The question came up, what does the bootstrap give us that's beyond what we get out of the Sobel? Why ever do the bootstrap? And so I had to think about that. I'm learning as we go a little bit. If you have more than one mediator, you can, from my thinking, you can skip the bootstrap, because all the bootstrap gives you is the estimate for the indirect effects. But since you have multiple indirect effects for every IV to DV relationship, you're not going to use that anyway. You're also not going to use the p-value for it, because that's through all the mediators. And so it gives us absolutely no additional information when we have multiple mediators. You can just jump straight to the Sobel after testing with and without mediator.
But bootstrapping doesn't disrupt your estimate.
No, so it's not going to hurt anything if you do a bootstrap. Now, if you only have one mediator, you don't have to do a Sobel test. You can just do a bootstrap, and it will give you the correct, accurate indirect effect and accurate p-value for that indirect effect. So, more than one mediator, do Sobel. One mediator, do bootstrap. Updated. Yay!
Yeah. Okay, so I'm doing a bootstrap because I have one mediator,
Mm-hmm.
and I'm trying to figure out what I need to use. So I'm going to write it up for my paper. And I know where the significance from, so figure out if the standardized or direct effect is significant or insignificant. What do I use for my path? So I have to say, you know, path A was this, path B was this. Do I just use the regression coefficient from?
Yeah, just use a standardized regression coefficient
Okay.
for A and B.
I would have to delete the mediator in order to get the direct path coefficient, right? Or is that provided for me?
So the question is, do I have to delete the mediator to get the direct effect from IV to DV?
Yeah.
You'll need it with and without the mediator.
So I would have to delete it in order to get the.
At one point. Yeah, you need to delete it. Delete the mediator at one point in order to see if there was ever an effect from IV to DV.
Okay, because I can get so when I pull up the analysis in AMS, it shows me the direct effect, which would be the effect of X on Y, but I don't see the coefficient, if that makes sense.
You don't see the coefficient from X to Y?
Yeah, so I can get the direct effect in the output, which would be, wouldn't that be the same thing? The direct effect would be
Correct. Yeah, so in the bootstrapped output, there's total effects, direct effects, and indirect effects. So if you want to see the direct effect, you go to standardized direct effect, and let's say we're doing information acquisition to decision, what was it, playfulness to information acquisition. The direct effect is 0.124. If we go look at the model, it's going to be roughly that. Playfulness to information acquisition, 0.12. Right?
Okay.
Just as, I don't know, to be comprehensive here, the total effect, this is all effects from IV to DV, both direct and indirect, all together. So in the case of playfulness and information acquisition, if you account for the indirect and the direct effects, altogether it's an effect of 0.387.
Okay.
Yeah.
So if we use the total effect, we shouldn't have to delete the mediator and run it multiple times, right?
You should delete the mediator, even if looking at total effects. I almost never use total effects. Total effects are still swayed by the mediator's presence.
Really?
Yeah, so the direct effect is still swayed by the mediator's presence. Oh, okay, yeah. So you still need to delete the mediator to see the direct effect without the mediator. Because this effect, this playfulness to information acquisition, with the mediator present is going to be lower than when the mediator is not present. because some of the variance being explained in information acquisition by playfulness is now being explained by usefulness.
So you should always delete the mediator to find the coefficient.
According to James, you should always delete the mediator at some point in order to get the direct effect without the mediator's effect. Influence. You then use a Sobel test to determine the significance of the indirect effect when you have multiple mediators, or use bootstrap when you have a single mediator. Yeah. The Sobel test will work also when you have one mediator, but a lot of people like bootstrapping, so that's when you would use Sobel instead of bootstrap, is when you have multiple mediators. All right, that's mediation. That is one of the most complex topics in SEM, if not the most complex topic, mediation. Hardest thing to theorize around, and is the most common weakness in mediation research papers, is the theory around the mediation, and also the testing correctly. So, consider yourself brilliant now, and a step ahead. More brillianter, I think is what I meant to say. Consider yourself more brillianter. Okay. Moderation. Woo! Unless there's anything else on mediation, I'll take questions, but we good? Good, all right. Moderation, so much easier. Oh my goodness, moderation is a walk in the park. Moderation logic, we talked about this. Automating, here's another example. Autonomy impacts satisfaction. How should autonomy impact satisfaction? What do you think, in general? Positive or negative effect? Positive effect. The more autonomous I am, the more satisfied I am as an employee. What might change that positive effect?
Knowledge.
Knowledge. So autonomy has a positive effect on satisfaction, and that effect is stronger when I have more knowledge. Cool, we can do that. Excuse me. Anything else that might affect that relationship? Self-efficacy. I think that's as much as I hate that variable, that's a really good variable in this situation. If I know what I'm doing and I'm confident in what I'm doing, autonomy is fabulous. If I don't know what I'm doing, don't leave me alone and tell me, oh, figure it out, you're good, do whatever you want. No, tell me what to do, step by step, give me a video. You know? So autonomy is terrible in that situation, so there might actually be a negative effect between autonomy and satisfaction if you have no self-efficacy. So anyway, great example. I love that example. So we talked about the logic. Here's another example. Focus should have a positive effect on learning. But that focus, this will be salient for many of you today, that focus is, the positive effect focus has on learning is dampened when you have less sleep. It's strengthened when you have more sleep. So you're able to learn a lot more as you focus, but boy, it's hard to focus when you haven't slept well. So we would say that sleep last night, the amount of sleep last night, amplifies this positive effect. In no case is focus going to have a negative effect on learning in this situation. It's just dampened or amplified based on the amount of sleep you got. There are two different types of moderation. There's multi-group or categorical, nominal moderation, and then there's interaction, which we tend to call continuous or metric moderation. The way you would model them is the same. So conceptually, you model them this way. You have the moderator pointing into the relationship. In Amos, you can't actually do that. You can't have a line going into a line. It doesn't work. That'd be cool if you could, though. So the way you model them analytically and test them, for multi-group, you create two separate models, one for male, one for female. And then you test autonomy to job satisfaction for male, and then you test it for female, and then you compare those effects and see if there's a significant difference. Yeah.
How would you consider for gender, for example, when it is put in a bucket? So is it categorical or continuous?
Gender bucket?
Sorry, for age.
Oh, age. I was going to say, that's a weird bucket. I'm in this general bucket over here for gender. For age, so age is more of a continuous variable. Oh, you have buckets for age. Then you could have either multiple groups. So you have youngins, the teenagers, the whatever. You got 4 or 5 groups. No, you could treat it as groups. Also, this is a tricky one. So age in buckets, still you increase the trait as you increase the value. So it could still be treated as an interaction, but it's not ideal because technically they're discrete. Because you could be anywhere in there and anywhere in the other bucket. I could be 7 and still be in a bucket with a 10-year-old. So if you wanted to split them into a multi-group, you could say, yeah, everybody in the first 2 buckets, they're young. Everybody in the last 2 buckets, they're not young. Everybody in the middle, we don't care about you, or you're in the middle.
Do you have to define how you did that?
You definitely, you get.
If there are 9 buckets, you derive that by the median by saying, okay, up to 4 is young enough to.
This is a good question. When you have a continuous variable, or roughly continuous variable, or ordinal variable that you want to treat as a multi-group moderator, what is the logic and justification for creating the split for the groups if you only want 2 groups, for example? The most common approach is to take a standard deviation from the mean or median and say everybody 1 standard deviation or more above or below belongs to the high or low group. When you don't have a lot of data, that's hard to do. Let's say you only have 200 and you're testing a complex model. Well, you just got rid of 60% of your data. More than that, actually, 64, I think, % of your data. By taking away everything within a standard deviation. If you have a normally distributed, I mean, that's terrible. So others will do it based on theory. So what do I think is old? In the context of my study, anybody over 25 would be old for a sophomore. Anybody younger than 20 would be kind of young for a sophomore. Everybody else is just in the middle where we expect them. So there are different ways you can do it, or you can just take a straight median. But typically a straight median isn't as powerful as a theoretically justified split point. So these guys are really old and these guys are really young, not just the median split. Okay, but you certainly can do that. The way to test interactions in Amos is to create a product term or an interaction term where you multiply the independent variable by the moderator, in order to create a new variable called an interaction, and then you regress the DV with that interaction. So we'll do both. We'll start with multigroup because that is way easier. We'll talk about that. And let's go test these. Okay, let's go test some. I don't have hypotheses listed, so I want you to pick one. Which, if we're going to use frequency and experience, let's start with frequency. Let me tell you about the frequency variable. Frequency, the question asked, how often do you use Excel? And the answer was once a year, once a month, once a week, multiple times a week, multiple times a day. And then we split that, so if people who used it frequently, they're in the high group. People who don't use it very frequently, like once a week or less, they're in the low group. And so you tell me, what do you think here might be moderated by frequency of use of the software? Let me explain to these others because they might not make sense. Atypical use is the extent to which I believe the way I use the software is different from the way others use the software. Comprehensiveness of use is the extent to which I believe I use all of the features or a large portion of the features in the software. Somebody texted a request. Oh, okay. Well, with nothing forthcoming, let's just pick one. How about, I believe the extent to which atypical use affects decision quality, that should be moderated by frequency of use. So the more you use it, then as you use it different from other people, that use will lead to better decisions. But if you don't use it very often and you think you use it different from other people, that's not going to lead to better decision qualities. You're probably using it different in a bad way, is my guess, rather than in a good way. So I would expect frequency to strengthen the relationship between atypical use and decision quality. All right. Do I have to test this with all the mediators and all the other relationships? The answer is probably a good idea. Yes. Because that is using your full window into reality. So let's do it. To do this multi-group, we're going to double-click group number. Actually, I'm going to save this as, save as multi-group. See you, honey. It was so good to have you. Good luck with things. Okay, I'm going to save this as path multi-group. Actually, I'm going to path frequency. Okay. We'll be back. Oh. Oh, okay. All right. So we resave this. I'm going to double-click group number 1. Call this high frequency. No, I better start with low. Here's why. In our frequency variable, 1 is low, 2 is high. So I'm going to start with low frequency, new, high frequency. We used to abbreviate it to be FREQ, but then you can't help but pronounce it freak, which doesn't work out too well. Okay, high freak, low freak. And now we need to go give that data. So we already have data for the first one. Let's go get the same data set for the second one. It's the composites for me. That's what I'm using. And then a grouping value and variable for this first one would be frequency category. Did we create a category for frequency? I think we did. Here's N frequency is the category. That's in the grouping variable area, N frequency. And then the grouping value for the low group is 1. We have 195 in that group. Second one, same thing. Grouping value is N frequency. And grouping value is 2. So now we have our group split in Amos. And hit OK. If I'm going too fast, I can slow down. People are trying to keep up. So a few. Yeah?
Yeah. Watching it seems like I did something similar or identical.
The invariance test. This is very similar to the invariance test.
So help me understand, how does one relate to the other? Or is it
Let me distinguish between the two. The procedure for testing multigroup moderation is the exact same procedure for testing a multigroup invariance. The funny thing is, for a measurement model, we want to find the groups invariant, not different. For a structural model, we want to find them different. Now, if we find them not different at the measurement model, are we going to find them different at the structural level? Possibly, because we're testing two totally different things. In the measurement model, during the invariance test, we were testing whether the measures, the squares, were related to their latent factors similarly across groups. In the structural model, we're testing are the relationships between those latent factors, now modeled as composites, are those different across groups? So we're testing something completely different, but using the exact same procedure. Yeah, so in the structural model, we're testing the relationship differences between composites, between those latent factors. Whereas in the measurement model, we were not testing that. We were testing the relationship between the latent factors and their indicators, something totally different. And we want them to be different here in the structural model. We don't want them to be different during the measurement model.
But that's possible because you're testing two different things.
Yeah, it's something totally different. Yeah. Yep, same procedure. Yes.
So I just want to make sure I understand this. So when we are hypothesizing a moderator, we always want to use an invariance test beforehand, correct?
Correct. When you're hypothesizing a multi-group moderator, you always want to do an invariance test.
A multi-group.
Yeah, if you're just doing interactions, Doesn't matter. Don't have to do an invariance test.
What's the difference between an interaction and a multi-group moderator?
No, you're good. I have slides on that. Okay. Multi-groups on the left, interactions on the right. Typically, multi-group moderators are nominal or categorical, like gender or education. Well, education can go either way, actually. Industry is a very common one, organizational studies, employee position or department, things like that. Whereas interactions tend to be more continuous, like age or satisfaction or whatever. Yeah.
So going back, because I remember we dichotomized a continuous variable for
Yes.
our invariance test.
Yeah, so frequency and experience were actually more continuous.
Why don't we just keep them continuous?
So that I would have interesting multi-group moderators out of this data.
Okay.
So I could test across gender, but that's my own.
Invariance by dichotomizing, right?
Very good. We are losing.
Real world, we wouldn't want to dichotomize. We want to keep it as a continuous, right?
Okay, so the question for remote folks is, first of all, we are losing variance, richness in our variable by dichotomizing a continuous variable, such as frequency or experience. And in the real world, we would never want to do that. The answer is you may want to do that. Interactions are a funny little beast. Oftentimes, interactions will not be significant. It is very, very uncommon to find significant interactions. Yes.
Really?
Very. Yeah. At least in all my experience, which has been on quite a few data sets, in the dozens and dozens range. Whereas multi-group effects are a lot easier to detect and more frequent. Yeah.
So, age, understand, would normally be a continuous variable, right?
The question is, age would normally be a continuous variable
For doing an interaction.
for doing interactions. And the answer is it depends on who you ask.
Okay.
If you ask me, yes.
Okay, so let's go with that. For a
Okay.
moment. Go into this little project that some of us are working.
Yes.
And I think the question may be asked somewhere already, but age is showing as a moderator.
An interaction.
But it's not, it's in the little buckets. You know,
Is it? Oh.
Isn't it?
I'm not familiar with that data set.
It's an age range. It's
It's about 9 bucks.
Oh, but 12 bucks, that's a lot of buckets. So you could pretend that's ordinal. It's not continuous, it's ordinal, roughly. And you can use an ordinal variable as an interaction. Yeah. Okay. And as you increase in the buckets, you increase in your age, right? Yeah, so you can treat it as a metrically meaningful variable. Yeah. Okay. So let's go test it. We started on it. We got to this point. We have groups. We have groups with data. We can run this and just eyeball it. Let me just run it here and eyeball it. So hit the up arrow. We're on standardized estimates. Our theory was about atypical use to decision quality, I believe. So for the high frequency group, for those who use Excel pretty often, atypical use has a positive, very small positive effect on decision quality. For the low frequency group, it's a slightly stronger small positive effect. However, if neither of these are significant, I can't say it's stronger because it's no different from zero. We can't determine its effect. So let's go look at the effect. Estimates, scalars, standardized regression, or no, we'll look at regression weights, and we're saying from atypical use to decision quality, right? There you go. Ouch. Way down here. For the low frequency group, the effect is significant at the 90% confidence level. For the high frequency group, it is not significant. So, this is the tricky part. Can I say then that our theory was, our hypothesis was supported? No, for multiple reasons. First, the effect is actually stronger for the low group. We theorized it would be the high group it would be stronger for. Second, the difference is 0.01 in a standardized regression weight. That is not a significant difference. We could test whether it is, but I can tell you now that's not a significant difference. And 3, A2D, the effect was not significant for one of them, which means we don't know what the effect is, essentially. And so we can't say it's different from some other effect because we don't know what the effect was. Unless they are so different as to be out of each other's range, which we can test.
So this is the standardized regression weight. So is
Correct.
Comparison?
I was just looking at the p-value. In the standardized, they're just one apart. So if we go down, here's atypical use, 0.106
Okay.
and 0.116. So they're,
Use the standardized to compare this.
yes, you would use standardized to compare the two. They're just 0.01 apart. Let's pick a bigger one.
I'm sorry,
Yeah.
can you restate your statement about,
Non-significant and telling a difference?
the non-significant, something what happens when one of
Okay.
the groups shows non-significance.
Let me show you something. Let me show you where it is. Moment. Where did I put it?
Can we not make any inferences if we don't have a p-value of significance?
But if you went from significant.
I'll just recreate it.
Can't you conclude that it's significant for one group?
From what
Oops.
I understand, it has to be significant because you can't
Move
make,
anything, you can say.
because you can't say that, so there could just be a lot of error in one variable, from my understanding.
Yeah, that makes sense.
So I think that it has to be,
Both significant.
yeah, I think so, I'm not sure.
Weighted, notably different.
Yeah.
Let me show you something. Okay, so this, we're going to plot two relationships on the same graph, which is essentially what we're doing. One's for male, one's for female, or low frequency, high frequency, two different groups. So here's the one for low frequency, pretty strong. Well, really it's down here, but this will serve a purpose here. Okay. Yeah, I know that's terrible. That's really strong there. We'll just pretend here. We'll just pretend. Let me color these shape fill as red. Okay. Now we have this one, and then this one is not significant. And so the question is, so red is not significant, blue is significant. The relationships are 0.01 apart. The question is, since blue is significant and red is not significant, we claim that there is moderation, that is, this relationship is significant for one group and not for another group, therefore it is different. The answer is no. Here's the line for blue. Let me make that more visible. And here's the line for red. Are these different? No. We don't know is the real answer. We have too much error to tell. And so we could not claim support, even if we theorized that the low group would be the more, the stronger relationship, we couldn't say, yeah, we have support for this hypothesis.
And is it also because you're hypothesizing that it moderates the weights, not the significance?
Correct, yeah, and that's what you always hypothesize that it moderates the strength of the relationship.
And the principle that you mentioned earlier, that if it's not significant, you really can't conclude anything.
Correct. If even if one of them is not significant, it's hard to conclude anything. Now, let's say this was not significant and it was over here, and this one is significant and it's over here.
You still can't conclude anything, right?
Unless, okay, so there's a test that allows you to take the standard error, so we're accounting for the error of both groups, and take the regression weight, and then determine if there's enough information to claim significant differences. It's a critical ratios test. And so in some cases, when those regressions are so different, when the slope is such a different angle, and the error in one of them is at least tight enough, and the error in the other one provides enough evidence that it's in a different location, then yeah, we can claim significant differences. And I'll show you how to do that. Yeah. If they're both not significant, even if they're in opposite directions, you can't claim a thing. Just can't. Hope this visual was helpful. Okay.
James, I need to know.
Yes.
So you establish the multi-group moderator, and you really want to see a difference because
You do.
even though when you're trying to consult for a group of scientists that are working on Tesla batteries in Vegas, you try to get a sense for the difference between the managers and the scientists.
Sure.
So therefore, when you have a theoretical construct, it stands up because it's across all industries. So now you're dealing specifically with the Tesla boys and those, and effectively you want to see the difference because you're consulting for an issue they have, and so you really want to, if you discover significance versus insignificant, where the managers don't view the construct.
Okay. This is
That's effectively what's driving the problem. So you really want to see it.
from a practical perspective. What can we claim here? If you have one that's not significant and one that is significant, you can claim with confidence that atypical use is a significant predictor of decision quality for the low frequency group, whereas it is not a significant predictor of decision quality for the high frequency group. That is true. And so, yes, in that sense, for management purposes, that creates a slide in your report. Yeah.
I know, yeah, James, because effectively you're brought in as a consultant to figure out.
Yeah, and so it's telling them there's no problem, there's no difference.
You know, I need convergence here. You're actually saying that there's got to be divergence, so I can understand where the issues are, even though I'm using a construct that.
And so what I would typically do as I write up findings like this, I say we did not find a statistically significant difference, but we can observe that this is a significant effect for one group and not for the other. Therefore, decision or atypical use would be a good predictor for decision quality for this group, but not for the other group. And so there's a difference. We're not capturing it in this particular hypothesis. Yeah, you always follow up on that stuff. Yeah. Okay. Let's see if we have a bigger significant difference. I'm going to run every. Oh, we had some questions. I'm sorry. Go ahead.
Well, it's on that. So just looking back at sort of the lower high frequencies, are you going to continue to use that?
Yes. Okay. So we're going to see if there is one that is a big difference, and we'll test that. So we're going to test every possible path, and we're going to create a critical ratio for every possible difference simultaneously. Even though we didn't hypothesize all of them, I'm just going to look at all of them real quick. In your output, you want to click the critical ratios for differences, just like in an invariance test. Or if you want to do it the old, slow, imprecise way, you can use a chi-square difference test. And that's very well supported by literature, whereas this is not. Okay, not yet. Okay, I'm going to run it, proceed. So all I did was check the critical ratios for differences. It's going to think about it for a while, get our output, and we're going to go back to the stats tools package and go to the group differences area. This was the initial purpose for which I created this tool. And we paste in exactly what it says, the regression weights tables for group 1. In this case, it's low frequency. Copy. Paste. Go get it for high frequency. So we got to toggle down here on the left, high frequency. Copy. Paste. And get the critical ratios table. In the pairwise parameter comparisons. Just as a side note, if you accidentally copy the whole thing with the pairwise parameter comparisons label in it, it will fail. You gotta just do the. This is terrible code. You just gotta do this table without the pairwise labels in there. Okay. Then click the button, and we see if there are any major differences. Okay. Here we go. There is only one major difference in this group based on frequency, and that is usefulness to information acquisition. Who is calling me? Google Hangouts. Did it hang up on people? El Centro, California. Don't think anything good comes out of El Centro. Okay, let's see. Other than San Diego, so I can say that. Okay. So this is a very large difference. And if we look at the unstandardized here, these are unstandardized regression weights, you can see there's a very large difference, 0.291 and 0.558. Let's go look at the standardized on, again, this is usefulness to information acquisition. Go to the scalars, here we go, unstandardized, or standardized, excuse me. For the low group, usefulness to information acquisition, 335 for the low group, 537 for the high group. So for those who use Excel more, the extent to which they find it to be useful affects the amount of information they can get out of it more, at a stronger degree. The more useful it is, the more an increase in usefulness increases information acquisition to a greater degree for those who use Excel more often. Makes sense to me. And that is statistically significant. There's no p-value written up. It's just a critical ratio. But critical ratios follow a pattern. Anything greater than 1.96 on an absolute scale is significant at the 95% confidence level. Anything greater than 2.5, is it 4? 2.58? I think it's 2.58. Is significant at the 0.01 level. So this is a highly significant difference. Something I learned last week. You can now plot this. Multi-group differences and slopes. So let's go. You want to see it? Yeah, Google. I created a video for it last week. So in Google, and I learned about this last week. Yeah. And so I made a video for it when I learned about it. So if you Google y equals, and let me highlight this so I can have easier access here. This one, that, there we go. Okay. Y equals, I'm going to plot y equals our m, our slope, or beta, is 0.291. That's our unstandardized, by the way, unstandardized 0.291x. We don't have an intercept, so we're just going to accept 0 as our intercept. And y equals 0.558x. Enter. Here we go. So blue is the low group, red is the high group.
Oh my gosh, you can see the exact point at which to change.
Yeah, and you can even change, so here's the red one now. So now we don't have the intercepts. So the intercept for both these is 0. We don't have an intercept.
Oh, right.
So but all we're seeing here is the relative slopes. And so this is a good way to eyeball, are these slopes different? Well, heck yes. And it's a much stronger positive effect for the high group than for the low group. Pretty cool.
What's your syntax again for your search?
Yeah, just plot y equals slope x and y equals slope x. Yeah, so that the 291 is the unstandardized regression weight x and unstandardized regression weight x. That's pretty cool.
So we can't conclude that at 0 the intercept.
No, we can say nothing about where they cross because we haven't input an intercept. But if you wanted to input an intercept, you could. It would be totally bogus. 1 and -1. Enter, and it goes here. You can even do it for other groups, and y equals let's go negative 0.222x plus 0. You can do it for as many groups as you want. So that's pretty cool. There are some amazing things you can do with Google that I'm still learning. Anyway, so that's fine. Yeah.
So, back in the regression weights on the
Uh-huh.
you could just eyeball look at the p-value, see which ones are significant, and then toggle back and forth between low and high frequency.
Yes.
And sort of that.
Yes.
What's is the advantage of putting it into the stats pack to get the z-score to see the significant, and then with the Google thing, you're not seeing if it's actually actually significant differences, so it's just for this eyeball.
Visualizing, yeah. So to repeat for remote folks, you can, in the output, just toggle between high and low frequency and see the differences and sort of eyeball it. See for who is it stronger or weaker, significant or not significant. That would have taken us a while with this group because there was only one significant difference. And that's why I did the critical ratios test, stuck it in the stats pack. To get a significance indicator, this is a z-score, another critical ratio, like the Sobel test or like an f-value or a t-statistic. And that indicates the amplitude of difference. And then in Google, I only put it there to visually represent that difference. And I wouldn't add intercepts like I've done here. That was just an example that you could add them, because we don't have the intercepts.
In a case where you got a significant z-score from your stats pack, but you have insignificant p-values for both groups.
You can conclude nothing.
That's back to our earlier conversation.
Yes. So it is very unlikely. Oh, here we go. Let's look at this guy right here. It is very, very unlikely you would ever get a significant z-score when you have both non-significant paths. In this case, we have non-significant path here. That p-value is not significant. And for this one, it's just moderately significant.
Wouldn't that just be a crossover then? Wouldn't it be that both of them by themselves are a wash, but when you look at the unique relationship between the two, that it would just be complete crossover? So
you see, it's a negative effect for one, positive effect for the other. So they're opposite. They're inverse each other. But the problem is this different from 0? Do we know that this is a negative relationship? Do we know that it's a 0.05 relationship? The answer is no. There's too much error. That p-value of 0.463, that says no, there's way too much error to even determine the slope. Yeah.
So it really says that 0.05, negative 0.05 is too uncertain.
Negative 0.05 is really question mark. That is, we have no clue what the true slope is. There's too much error. Yeah. And while this one is significant at the 0.05 level, its difference between this one is indeterminate. This is significant at the 90% confidence level, not 95. So I would be very hesitant to conclude much off of this, except that for the high frequency group, comp used to information acquisition is significant, whereas for the low frequency group, it's not significant. That's all I could conclude is it's good predictor for one, not for the other.
And of course, if you hypothesize something and they came up out of this with not being significant, but you found something cool, like useful, you wouldn't.
Okay. Yeah. So the question is, so we only hypothesized about 3 or 4 multi-group moderations, but we tested every possible one. Turns out all of ours failed, but there were 2 or 3 that were pretty slick that we didn't even think about. What do you do at that point? Typically, you'd report that all of those hypotheses were unsupported, but in a post hoc analysis, you found some very significant things, very interesting things that you would then discuss in your discussion section. We just did that in a paper I recently submitted. Yeah. No, so I have a. So the question was, can you have a completely different model in your post hoc? Funny enough, I have a paper that tests one model, and then in the post hoc we show a new model that would be probably a better model, but it's not what we theorized. So that's for future research. Yeah. Yes.
Usually in regression, what we do is we put our first ID and then we put our second ID and then the interaction term where we multiply the two of them together.
Yes, we haven't done that yet.
Oh, okay.
We're only on multi-group right now. We haven't done any interactions yet.
So I guess I'm confused because even when you have multi-group moderation, you're still multiplying 1 times 0, right, in your regression equation?
Not that I know of. 1 times 0?
So like, let's say, for instance, I demi-coded my variables. So I only have 2 variables, 2 categorical variables. Maybe I'm looking at male, female, time.
Oh.
You see what I'm saying?
Oh, and a binary. Okay, no. So okay, the question. I don't know if I want to repeat the question. Let me clarify. As we're doing the multi-group moderation split, we're not multiplying regressions by 1 or 0. At this point, what we're doing is we're saying, for this subsample of our data, run this model. And then for this subsample, run this model. And then let's see what the estimates are from the different models and compare them. There's no actual we're not multiplying by the value of the group. So in our case, the group value was 1 for low, 2 for high. We're not multiplying by 1 and 2.
So we're trying to understand across all these different variables that differs by frequency of use.
Yeah, by group membership.
If I
Yeah.
was doing an interaction term, it would just be
a multiplication. Yeah. So next we'll do interaction where there's multiplication going on. Yeah. We have 15 minutes until a lunch break. I don't know if we're going to be able to hit all of interaction before then, or we can take a slightly later lunch, or just cut early and then hit it after lunch. So do we have a preference? Yeah. It's just we don't meet again for 2 hours, so anybody who wanted to, we have a few other things to cover though too, homoscedasticity, multicollinearity. So all right, let's hit it after lunch. That's all right with everybody. Hang out, folks. Any last requests before we come back at lunch? Yeah, he says after lunch, is it necessary to control variables? We talked about that. What is the threshold to know if there is too much error for a group and if the estimate is negative? Milagros, the answer is if there's too much error, the p-value won't be significant. So that's the indicator, is if the p-value is not significant. Okay. Cool. So I'm going to stop this broadcast. We'll pick up at 2 o'clock, hopefully for a slightly shorter session. Thanks, guys.